Good morning, good evening, good afternoon, wherever you are, whatever time it is. Welcome back to another OpenShift Twitch streaming session. We are not only streaming to Twitch, we are streaming to Facebook Live and YouTube Live as well. Please follow us on Twitch if you haven't already. And I'd just like to kick off today by introducing Raffaele Spezzole. I think I said that right.
Right?
Close? Yeah.
Close,
Okay.
close.
No. So I am from the South of the United States, so I have a hard time pronouncing things. So I am working very hard on these streams to pronounce people's names correctly. So I'm trying. I will get it right eventually. But thank you again for joining us again, Raffaele. And I hope that you can provide. I'm Chris Short, the Principal Technical Marketing Manager at Red Hat on the OpenShift team. Raffaele is, introduce yourself, please, sir.
I am an OpenShift architect in the services team. So I help customers get started with OpenShift and both the infrastructure side and application onboarding side.
So yeah, today we're talking about ServiceMesh and SRE monitoring within it. And, I want to remind people from the SRE book that monitoring is the foundation of SRE practices. So this stream is kind of like ServiceMesh 101 monitoring, I feel like, right? Like this is the must-have, right? This is the minimum viable monitoring that we're about to go through today, I feel like. So if you have any questions, please feel free to punch them into the chat. I will get Raffaele to answer them for us, and we will have a wonderful discussion. I mean, I'm sure I can answer some questions too if you have them. So feel free to ask away. Feel free to discuss amongst yourselves whatever solutions you've come up with to solve your problems, and let's just have a nice, fun stream here for a little bit. So, Raffaele, why don't you take it away for us, buddy?
Yep, sure. Thank you. Yes, so as Chris said, I would like to share some considerations on SRE monitoring and specifically in the service mesh. The general concepts are valid even outside the service mesh, but there are some things that become very easy in the service mesh due to the fact that there is uniformity around the metrics because they're all generated by the Envoy sidecar. And so because of that, you can highly automate the creation of these metrics and these dashboards. So that's why we are talking about, we're going to see the examples running inside the service mesh. And like Chris was saying before, monitoring is the foundation of the SRE practice. And if you read the book, you get the feeling almost in every chapter that this is a lesson that Google learned in a very hard way.
Yes, they did.
and it's the NFR #1. No matter what the client says, no matter what the team says, if you don't have monitoring, you cannot even be in the SRE. They will essentially push back with regards to managing your application, and you have to manage it yourself. So it's basically monitoring the way they want it is a prerequisite to be even considered for your application to be considered to become part of the SRE managed application.
Yeah,
at least
foundational level,
yeah.
Right? Like, and the SRE practice in general, right? Like, I mean, when it comes to anything, like when it comes to cloud, right? Like, it could get out of control very quickly, right? If you're using public cloud providers or even your own, cloud, your hybrid cloud. So, like having that base level monitoring instantiated across the board immediately upon any service launch is critical because things will get out of control without it.
Right. So that's what we're talking about today. It's sort of a coincidence. I was not really trying to start from the foundation because they were the foundation. It's just that I found this concept more actionable than others because the rest of the pyramid is really process heavy and less tool technology heavy. But monitoring is actually, there is some process around it and you have to be disciplined, but there is something that we can do from a technical perspective and actually build and make sure that our our applications are correctly instrumented, metrics are collected to a Prometheus instance, for example, and we have dashboards and alerts. All of that can be done uniformly across several applications and can be automated. So that's what we are focusing on today. But first, a little bit of theory around how some of the concept of SRE monitoring. I'm not even trying to cover all of them. You can read the book if you want a full exhaustive coverage, but I think these were the ones that were the most interesting for me. So normally, traditionally, when you talk about monitoring and you talk about availability, people think in terms of uptime divided by total time, right? But at Google, they decided to take a different approach and try to answer a different question, which was how many requests are we successfully serving over the total number of requests? So the time concept goes away and we count the requests. And that represents probably better the point of view of the consumer, how the consumer feels about this service. And it was kind of a necessary transformation at Google because when you are scaled geographically, there is always something that is broken and the rest is working. So the point is, how well are we serving our customers, knowing that there is always something broken, right? So that's important. And but immediately the next question becomes, what is a successful request? Can we measure it automatically, right? And to do that, you have to define what it's called in the SRE book, SLI, okay, service level indicator. That really depends on your service. What is a successful request? And you may have to measure different aspects. Like you may want to measure get to request different from put to request. But in a very general, high level way, we could say that for a REST type of service, a request that returns any of the 500 code is an error request, and everything else is a success, right? We could say that, and that would probably be a good way to start, and from there you can refine. Oh, and then you can also compute latency. You can also say, for me, a request is not successful if it takes longer than X, maybe 1 second, and everything lower than that is success. So once you have an indicator that says if your request was successful or not, then you can give yourself an objective. So that becomes an SLO, a service level objective. And you could say, I want 99% of the requests to be successful, 99.99% of the requests to be successful. That is really your team objective, which should be agreed upon with your line of business, with the understanding that the more nines you put, the more expensive it's going to be to build that system, right? It's a trade-off. And once we have these two definitions, we can start building Prometheus queries. So we assume we can collect the metrics in Prometheus, and then Prometheus has this nice language called PromQL that allows us to make these queries to see if to count these requests. So in this case, I have code in this slide just to make the point that this is all actionable, and you can actually do it today, right? With the tools that we already have in place. It's not that I don't expect people to be able to read this Prometheus query language, but it's here to say you can do it today, and somebody in your team will have to learn how to do Prometheus from QL, and it's not even that complicated. See, the query is not long.
PromQL is nothing to be scared of. I mean,
Yeah.
Yes, it is syntax heavy, but it's not that bad.
Right. So we can count the successful request, we can count the total request, and our SLO is given by the ratio of these two, right? Another concept is the concept of error budget. The idea is that given an SLO and given an observation window, which usually is 1 month, and given an amount of requests that are coming through that observation window, we can calculate how many requests can fail while at the same time leaving us within the SLO, right? That number of requests that can fail becomes a budget for our team. We know that we can spend that budget to take outages, to do maybe upgrades or to release risky features or whatever it's going to be, right? Um, Again, the error budget can be calculated. In fact, um, we have here this is a Boolean expression that says if at this point in time you are still within the error budget or not, but you can actually calculate the error budget if you play around with this expression, okay? So now this is where it becomes very, very interesting for me, which is how do you use the error budget to do release management, okay? And the rule, well, I mean, if you read the book, there are many variations, but the general concept on this rule, but the general concept is if a team is within the error budget for the last month, say, they are allowed to release new features. If a team is not within the budget, it means their code is too unstable and they're not allowed to release new features. They have to work on stabilization tasks. So conceptually, there is a backlog of stabilization tasks. Maybe it's NFR, maybe it's something that is coming from a blameless post-mortem that is going to make sure this problem doesn't come again. Maybe it's just more tests, but those are all stabilization tasks, and then there are new features. So when a team is not meeting the error budget, and at Google, if you do that for too many months, you're pushed back and you get out of the SRE team and you have to manage the application yourself. But let's say if you're not meeting the error budget in a normal situation, you have to work. It's all hands on the stabilization task. And I think this is it's a brilliant self-regulating mechanism because if you are going too fast in the way you release and the code becomes unstable, you have to slow down, right?
Yeah,
And it's data driven. There is no debate between the ops team and I have been in many meetings where it's the question never comes out very clearly, but what people were discussing, the dev team and the ops team were discussing about the speed of change, right? And the ops team is always as interested in slowing down, and the dev team always is interested in going fast. But what is the right speed? This mechanism self-regulates the right speed, and that's what I think it's so brilliant about it. So I think in some shape or form, we want to get to a point where we can add this little tool, this little idea to our release management process. Okay.
Yeah.
So another thing that, so let's say we decide to do that, right? Then the next question that I would ask if I was in a dev team is, okay, now I don't want to run out of error budget because that penalizes the speed of my application. How can I be alerted when I'm running out of error budget? And so there are some best practices that you can learn from the SRE book, a very famous chapter around how to create alerts in an effective way, because an alert should have the properties that are on the left here in this slide. So precision is essentially the number of false positives, right? So when you raise an alert, even if there was no condition to do it. Recall is the false negative, right? When there is there is some relevant event, but there is no alert generated. And then the detection time is how fast we can detect the alert, basically how fast somebody gets a page, given that there is a condition for an alert. And the reset time is how long it takes for the alert to stop, right? When the condition is resolved. Because what we want to avoid is to send alerts that are not needed or that are not meaningful, because that creates alert fatigue and then people stop listening to them. And so the best practices are to, first of all, alert on the budget burn rate and not on the error rate. And I see this like your first temptation is going to be to alert on the error rate, but again, I would direct you to the chapter in the book here that is in this link to where it's well explained why it's a better idea to alert on the budget burn rate. And then the other best practice is to alert on different burn rates. So you could have a slow burn rate and the fast burn rate, and you could associate the fast burn rate with a ticket, with a page that you have to react immediately, even during the night, and the slow burn rate with a ticket that you can react to maybe in the next morning. Okay. And then you also need a shorter observation window, shorter relative to the main observation window, so that you can, it's a sort of control set that will help you keep the reset time short. Okay. So this is an example of how the alert dynamic works. If you set up the alert the way it's suggested by the SRE community, which I call it the SRE community because it started as a Google thing, but it's now something that has a
Yeah,
life of itself,
it's
right?
gotten a lot bigger in
Yeah, yeah,
its own little way.
yeah.
Yeah.
So let's take this example where at minute number 10, we have about 10-15% of the requests that start to fail. Okay. There is this error rate short observation window. This is really a burn rate that starts firing almost immediately. So because this is the threshold. Okay.
Mm-hmm.
But we have set up our alerts system so that both observation windows need to fire for us to send an alert. So after about 5 minutes, also the long observation window starts to fire, which obviously it's slower because it needs more percentage of failed messages to actually fire. And because we are observing from here, the percentage is still slow.
Yeah.
So at this point, we trigger an alert. The guy on page is wakes up and in about 5 minutes fixes the problem. So the errors go to zero, right? So it was very good. And we can see that almost immediately after about another 5 minutes, also this short observation window goes to zero. And so at this point, we stop sending alerts, right? Because this window, this measure goes below the threshold. But look at the long observation window. It keeps staying above our threshold for another hour, more or less. And if we didn't have the control, the shorter observation window, we would have been firing alerts for another hour. So that's why the short observation window exists, to keep these alerts, this continuing of firing of alerts as short as possible. And you see, after the error rate goes to zero, ideally we don't need to fire alerts anymore. But in this graph, it keeps firing alert for another 3-4 minutes. Okay. So you may wonder, okay, how do I configure all of these, all of these alerts so that they fire correctly as in this dynamic in this graph? So there are some agreed upon best practices. This is some sort of magic numbers that have been experimented by Google, and then the community also added some. I think added a row here for even a longer and less and low priority observation window. So the way you read um, this kind of table is that is that you want to be alerted via page, so an urgent alert, if the error budget burn rate is 2%, 2% of the month in an hour. Okay, because this is the observation window. So this is a fairly fast burn consumption rate. In fact, it's 14 times the consumption rate that would bring the error budget to 0 in a month. So this can be calculated, and then the control window is 5 minutes because it's 1/12 of the long window, and that's another best practice. So you get all, so you get all of your numbers here, and then you can input these numbers in. So from here, then you can generate a Prometheus rule that will generate the alert. And there are even, tools or helper tools that can generate the Prometheus rule for you. And in our demo here, I created a Helm chart that will do that for you.
Oh, cool.
Yeah. Okay, so let's go to a little bit of a demo.
Can you drop that link to me somehow, some way?
Sure, this one. Yeah.
Yeah. Just so people can follow along if they want it. I can drop it in chat and everything.
Yeah. Let me see.
I despise typing, so I make people copy paste.
That's okay. Just need to find this.
And I don't mean to slow you down, but
no, it's okay. It's okay. All right. So this is our demo, and this is the link that I just dropped. I have already prepared some of these steps. Okay.
Sorry, I see like a grayed out box in the front of your screen. It's not actually displaying anything.
It says that resume share. Okay. For some reason, I was in pause of the sharing.
That's weird.
Right. Okay, so let's just to get everybody up to speed with what we have. So I have created, I have deployed Istio in the Istio system namespace here. It's the OpenShift ServiceMesh version of Istio. I have deployed the classic book info application. Ooh. And I did it too fast. So as you can see, nice that every once in a while we get some errors, right? As you can see, there is only one container. So for some reason, the sidecar has not been injected.
Ooh.
Let me see if we can fix this. So if I go here, I should be able to just do this. And do a delete and then a redeploy. Hopefully it's going to work. Yeah, when you do it too fast and the service mesh control plane is not up and running, it just doesn't inject the sidecar. Let's see what happens now. Yeah, so now they are being injected, as you can see. So we have in a minute we will have the book info application up and running, and then I have a SRE monitoring stack here, which is comprised of Prometheus, Grafana, and Alert Manager. I had to build a parallel stack to the stack that is already present in, as you know, in OpenShift ServiceMesh because of some limitations of, because basically the stack that comes with OpenShift ServiceMesh today is very locked down and they couldn't customize it. So this basically has the same metrics that we get in OpenShift ServiceMesh plus the metrics plus Grafana has two data sources, one to this Prometheus here and one to the platform Prometheus. So we can also see the platform level metrics. Okay. At this point, we are ready to start the demo. And so what I'm going to do is to deploy something that generates loads. In this case, I'm going to deploy Locust. Okay.
Can you increase your font size a little bit if you don't mind?
Sure. Just remember how to do it.
Control ++.
Yeah, is it working? Yeah. Okay.
There we go. Thank you.
Okay, so, and then I can start this, it's called swarm, where I'm gonna, basically there's gonna be a couple of threads pinging the book info application. Okay. So that is just to have some load. So now if we go to Kiali, right, we should see that there is some load. Let me see.
Logging in, all the fun things.
Okay, so I like this graph. Book info. Not good.
Live demos.
It could be that there is not enough metrics yet, but
yeah, it's only looking at a 1 minute time span.
not good. Okay, I'm not sure what's happening.
That's weird.
Okay,
so,
let's get
yeah.
a confirmation from another source, which is our Grafana here. Yeah. Oops, our Grafana here. If there is really no metrics coming through, when no connection coming through, then there is something broken in the swarming piece.
So what Raphael is doing right now, he's jumping into the actual Grafana dashboards that come with OpenShift.
Yeah. Where are the dashboards?
Where'd they go? Where'd who go?
Yeah. Oh,
sorry.
Dashboard. Oh, I thought there is supposed to be a.
There's supposed to be pre-populated ones.
Drop down list box here, right?
What in the world?
Okay. We have another option.
let's
go.
Okay.
Yeah, let's go to my SRE's monitoring stack, which should see the same data. And here we have something. So let's go to service dashboard.
Here we go.
Nothing. Wow.
Weird. Have you tried? Is there any like actual workloads or things that we need to try and do to generate data? Is there anything else that we need to do?
There should be something. Anyway, because we.
Weird. That's very unusual.
Yeah, because it was. Okay, let me see one other thing.
Always something.
Okay, so this is, this is what you do when you want to debug this stuff.
Dive right into
Prometheus. You go to Prometheus and you see if the scrapers are up, and they're all up. So nothing seems to be broken. And if we try to collect, or there should be an still.
You got an extra T in there.
Oh, is.
Yeah, if there weren't
or
so many
HTTP.
other fun things.
Yeah, I have a bunch of other stuff, and that's true. Okay, this is, for example, something that should exist. And yeah, it's it.
Yeah. Okay. Interesting.
Oh no, these are not the right ones. There should be.
Let's see.
I don't see the.
What in the world? It's not like Kiali or something named silly, right? Like we didn't skip
Well,
over
there
it, did we?
is. Okay, let me check something else. Let's go in this one.
Yeah. This is a very unusual problem.
We'll see. But you know,
Narendev said yesterday I tried STO4 or STO1 4x service mesh and OpenShift Playground 4.2. The STO service pods were all ohm killed and crashing.
Yeah.
How would I work with it there? I have not seen that problem.
Okay, so here we have a better view of the.
So this is in your actual project or in the STO project?
Right. This is the STO project.
Okay, got it.
So we are actually looking only at those metrics. So we have very little metrics. So it's like it feels like there is no. Let me see. Let's run this through. Feels like there is no way for the swarm to actually. No, but these were already up. And let me see what this says.
Is that the default login page or something?
Yeah, I want to see.
Oh, that's a simple bookstore app.
Yeah, I want to see if I can talk to that.
Well, you just did.
It could just be the router answering.
Yeah.
I need to. I'm gonna do this awkward way too.
We're gonna do some troubleshooting here, folks. So yeah, if you curl with high verbosity, or you could have done, I guess, a -I just to get the header.
Yeah, so this seems to be working correctly. So, and I bet now we're gonna get some metrics over there if I make some requests. Still nothing. That's weird. I don't know why they're not coming through.
What in the world?
Oh, okay. So this is now.
There we go.
Showing, yeah. So the swarming is not working. Let's see. Let's try again. With, sorry, I'm a little lost, but no, here. Okay, the swarming. From here. Let's see if we run this again. Something else. But it did respond the right thing before, so I assume it was working. It says swarming started, but
okay. I mean, yeah. Let's see.
It's actually not started. All right, let me see. Echo.
There you go.
Locust URL. Let's see what's going on with locust. Because without a little bit of load, we can't.
Yeah, we got to get something pushing here. Well,
So,
it's doing something.
Yeah, it's doing 30 requests per second. So what is the problem?
It's running 2 users.
Yeah, it's running just
yeah. So like you would think this would generate enough to make this page.
Okay,
Oh,
okay.
there we go. Okay, it's coming. Yeah. Stats take a little bit to gather
traffic
up.
animation. This is what. Okay, cool. All right. So as you can see, after about 20 minutes of troubleshooting,
once you've actually generated enough traffic,
yeah, we now have traffic. Now what we're gonna do is to inject some errors. Okay, and we use the nice feature of Instead to do that. And I'm going to inject about 10% of 500 and 10% of latency above 1 second. Okay. And so now we should start soon seeing some errors here.
Give me errors. I wonder what the delay is.
I don't know, but there is clearly a delay because.
Oh, you're moving your mouse. Sorry. I got excited for a second. I'm not seeing any 400s or anything coming in. I'm not seeing any errors. Nothing.
Nope.
Is this your cluster or some clean cluster you spun up?
Here we go. Here we go.
There we go. All right.
There's some delay. Okay, so exactly the details service is going to fail. Okay, so with this, we can finally go to see our error budget dashboard, which is in our SRE monitoring Grafana, which I think we already opened, but let's open it again. And we have this error budget.
So many errors. All right, let the errors.
All right. So I don't know why this clip keeps moving here, but it's supposed to. Somebody good with Grafana, please help me build a nice dashboard. But
yeah.
Okay.
Terrible at dashboards, man. It's okay.
So these are just 4 different representations of an error budget. I was preparing this for a customer. I just didn't know what they would have liked. So, but I think the one here on the left, for me at least, are the most interesting. So one shows availability, right? So this is our target error budget. No, wait a minute. This is 95 is our target.
That's the objective, right?
That's the objective, and we are. I think this is a little bit again of delay.
Yeah, there is definitely lag here.
We're still not seeing the fail request, but as they start coming through, we'll
start seeing it.
Yeah, maybe we come back later here in a few minutes. But here we will see that. Oh, wait a minute! It's a wrong service. We have to look at.
Oh, well, I'll do it.
Okay.
There we go.
That's what it was.
Oh yeah, that thing quickly fell out of budget.
Yeah. So what I wanted to show is that this is our objective, the yellow line, and we are going down because, of course, it's failing. I'm injecting a lot of error. Also, the observation window here is very, very small, right? You should be observing 1 month, but I'm making this quick so we can.
So
look at it. Yeah.
So I see this dashboard, right? Like I think, okay, it's out of budget. Something's horribly broken. I need to get it back in budget. Now, obviously here you would just turn off the error generator, but working towards getting it back in budget takes time because, you see the lag here, right? Like imagine if you're looking at it at a 1 month scale, right? Like if you fall out of budget over a month, it's going to take you to get some time back into budget, right? Like just because you're up doesn't mean you're back in budget. So people have to remember that with SRE, right? Like if you're out of your budget, you're out of your budget for a long time. right? Like
Right.
these are
Right.
periods of time measured in days and weeks,
Yeah.
not minutes and seconds. So that is something very, very, very important to consider here.
Yeah. Things will happen on a larger time scale.
Right.
So it takes a little bit longer to get out of budget, but also a little bit longer to get re-enter in budget if you
Mm,
have consumed a lot of errors. And
right.
that is why the canary release approach is becoming more and more popular, especially for
Absolutely.
people using this error budget concept. Because with the canary, remember, you do like 1% of the traffic to the new release.
Mm,
So even if something is wrong with the new release, you're going to consume very little of your error budget.
right. Yeah. Get the service out there slowly but surely.
Right.
Make sure you're monitoring for error budget, right? Like there's an expectation maybe of an error here or there as you're transitioning, but it shouldn't be dramatic like this at all. It should be very, very subtle
Yeah. Yeah.
as you
Yeah.
roll more services to the new build that you just deployed, kind of thing.
Right.
So yeah, blue green
Here it's
deployment, canary
exaggerated.
deployment, those kinds of
Yeah.
things are all very, 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 very smart ways to deploy, especially container-based services across OpenShift, Kubernetes, wherever.
Right.
um the the biggest thing I think SRE gives people is like actual math, metrics, hard, concrete evidence of there's a problem here and it needs to be fixed, right?
Right.
Like ops teams, you can say, yes, it's up, yes, it's down, but now you have the capability to say, hey, this service, this feature, this whatever is definitely in need of some help. And
Right.
you have the math, you have the calculus to actually go back to whomever and say, hey, please help us reduce the error rate here because you're way out of budget for this service. And otherwise, we have to do something drastic, right?
Right.
So I think that is like the best piece of ammo that SRE gives ops people. And conversely, for developers, right? Like you want to know your services are performant
Yeah. Yeah.
and
It's
within
useful to developers too, because they
yeah
now have a
if
metric that is shared.
right
Especially if you think about it,
and
our budget
you
is
can
a three-way social contract between ops, devs, and the line of business.
the line of
If
business, right? Like the business is definitely involved here.
Yeah, if everybody agrees that that is the metric that needs to be followed for everybody's success, that also, that gives developers a very nice way to prioritize.
Right. So yeah, you can quickly say, right, like, okay, here's where in the backlog we need to focus
Hmm.
and where in the new feature chain we can go based
Right.
off of that. It's very, 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 very helpful across the board, especially if the line of business is actually involved, right? I've
Well,
seen SRE done in kind of yeah, between the dev and the ops team, it's SRE, but the line of business doesn't care, right? And that
yeah,
doesn't work,
that
right? Like
doesn't
you
work.
have to have the line of business being, very, very willing to say, all right, ops team, you're handing this back to the dev team and they're managing it until it gets back in tolerance so that you can manage
Yes,
it again. Like
yes.
that
Basically,
requires business
yeah,
buy-in.
yeah, they have to be willing to give up a release of new features for the sake of improving their budget.
Bingo.
The developer.
Right.
Yeah.
Right.
So
Like
they
you're
have
not
to
going
be
to just
bought in.
march features forward
Right.
without having stability.
Right. So one thing I wanted to point out here is that this is a generic dashboard where everything, is the service is a
Mm-hmm.
parameter, the service objective is a parameter. So with one dashboard, we could control all of the services in this mesh, because what I said before, it's very uniform in the way, in a
Right.
service mesh, very uniform the way the
Oh yeah.
metrics are collected. Normally, this would not be true. Normally, each service, each application would come with their own metrics, different names, different purpose, and you would have to build a specific dashboard for each. You can still do it, but it would be
Mm-hmm.
specific for each.
Yeah.
So we have a little bit more to go here, and not much time, so I'm gonna speed up a little bit,
Go
and
ahead.
go back to
I'll
the
stop interrupting.
presentation. um, so uh, there are some limitations with this approach, especially around the fact that this is a statistical approach. So if it assumes that errors are normally distributed from a statistical perspective, and if they're not, you could be missing some interesting use cases. I'll
Mm,
give you the link to the presentation if you want to read this in more detail. But I wanted to talk about more general monitoring, because now we have focused on error budget and how to alert on error budget. Okay, actually, I
yeah.
didn't show you the alert part, but there are also alerts being generated. But one could say, well, okay, but what else should we be looking at in terms of metrics, and should be creating dashboard around? And there are two main line of thoughts in the space of monitoring, which are the use method and the red method. The use method is more of a white box approach, where you assume you have access to the internals of the service, and you can collect metrics around user saturation and error for the main resources of the that the application uses, which usually are memory, CPU, disk, and network, disk I/O and network I/O. The red method is more around, it's a black box type of approach where and there's supposed to be a box here, a closed box, but I don't know, it didn't render.
Hmm,
But it's a more of a black box where we observe the behavior of the application from the outside, and so we look at the number of requests it's receiving. If it's REST, this would be HTTP request, right? We look at the error for these requests, and we look at the duration of or latency of this request. And then there is the four golden signals, which is what Google and the SRE community actually use, which is a blend of the two. It's essentially the red method plus saturation, which is something that you have to do through a white box approach. But essentially, those four metrics will give you enough understanding of the of the behavior of the service. And in the four golden signal, the saturation is not really saturation of the basic compute resources, but it's really more saturation of the system. So instead of just memory, CPU, you would look at if the system, for example, is a queue. Are we filling up the queue and get to a point where we cannot accept any more messages?
nice.
Okay. And the idea here is that if we understand enough of our application, we can start alerting on these metrics, and we can alert in a way that we alert before an error starts to happen. Because if there is an error, there is already the SLI and SLO
Right.
alerts that are going to tell us there is an error. But here we can probably do some preemptive alerting. Um, and saturation is a nice metric to do that, because it's telling you, look, the system is about to be saturated and probably it's going to break, right?
Mm,
um, but also the others, like if you know that if there's starting to be errors that you don't expect, that's probably a signal. And if you know that your system can only accept so much traffic and there is more than that, that's another signal. um, and in general, the idea for an SRE is that not only you want to be preemptively alerted, and that is the minimum, right? And then you do something about it. But if you know what needs to be done, if you know what what the cause of the problem is, and if you know what needs to be done, you can use the alert as a trigger of an automation and do preventive maintenance, not just preventive alerting. and and this concept has actually been there for a while in OpenShift and in Kubernetes, right? The horizontal pod autoscaler, for example, is just preventive maintenance based on CPU saturation, right? And that's how it works. And recently they added memory saturation. The vertical pod autoscaler does the same thing, but it scales up the pod, right? Instead of vertically, it creates bigger pods instead of more pods. Knative is a different as a different autoscaler, right? It scales on request per seconds, but again, it's again a preventive maintenance. It's you decide that the system needs to be scaled when the length of the queue is so much, all right, and then that's the automation that serves the metrics and reacts to it. KEDA is another one that it's interesting, right? It's the ability to auto-scale based on metrics that are external to the cluster. So you are observing something else outside of the cluster, and
Like some
And
massive attack on your boundary or something, right? Like, yeah,
well, it was
it
designed
could be anything.
if the queue of requests is in a managed, like this is come from Azure, I think. If it was designed to they have a Kafka managed service, I think, and you could observe the length of the queue there instead of something running inside of OpenShift
Mhm.
or Kubernetes. But I mean, it's generic enough that you can plug in your own metrics. And then I've tried to imagine like what else can we do, like, and one thing that is easy to imagine is a disk auto extender. Right now that we have the feature for most disk provider to extend the disk, we could create a controller that looks how much you're using of the disk and auto extend the disk when it's about to fill up, right? That would be an easy kind of preventive maintenance based on saturation that we could write. So you could create generalized use dashboards, right? And you can create a generalized red dashboard, especially for things running in the service mesh. As a general concept, the use metrics or user related metrics come from the platform Prometheus. That's why we need that second data source to source them. And then the red kind of metrics can come from Istio and the observability stack in Istio. So let's go and take a look at this dashboard if we have still a minute.
Yeah, you got all the time you want. You're the one with the hard stop, buddy.
I know, I have a hard stop. I apologize. So first of all, very quickly, let's take a look if we actually have alerts that are being generated. And we have to log in everywhere. But oops, nothing.
Oh, here we go again. Let's see.
Okay, we don't have time to debug this. I don't know why, but we should have seen a few alerts here being generated. And then obviously, if you attach a destination, then they would actually be forwarded somewhere. Right, strange. Let's see. Well, I said that we have no time, but I'm curious. Oh, there is no alert rules defined. Okay.
That'll do it.
That explains.
That'll explain that one.
Okay, so let's go to our use and read dashboard that we have created. So let's do the Istio use method. We don't need to save. So as you can see on the row, we have the resource, kind of resource, the CPU, and so on. And on the columns, we have utilization, saturation, and error. We cannot get all the metrics, all the kind of metrics for all the resources. There are some things that are not easy to do in general, and something that cannot be done inside of OpenShift. For example, for network saturation, you can do it only if you know the bandwidth available, which is not an information that is discoverable inside of OpenShift. But in general, we can see that the metrics are being collected. And again, it's pretty generic. Like I can choose the namespace and I can choose the service, and this, if I choose ratings, this will refresh and show a different set of pages or panels. And for the red approach, we have another set of panels here. Okay, we have details, that's fine. And I don't know if you can see, because we don't have a lot of, actually, if I reduce this a little bit, we can see more in the page, the last 30 minutes, okay? So we can see here that there are a bunch of them that are around 1 second, and this is that 10% of a request for which I am injecting an error, right? All the others are very quick, like they are around, what is 50 milliseconds or 10 milliseconds. So this gives us an idea of the latency, and then we have errors and requests per second. Are the red kind of metrics. And I need to stop here, but I think we covered most of it. Unless there are like pressing questions, I think
there's no pressing questions in chat. I think I've got them all covered. Okay. Kita looks interesting. Yep, they are. We've worked with them, off and on in the past. Can I provide a link to Monday's Windows Server Containers show? If you're on the Twitch stream, you're in the right place. There's no pre-generated links for shows on Twitch. You just show up and it's there. Let's see. Well, Lead says he just needs to kick the tires on it some more. Yeah, no, that's it. Thanks for your time today, Raphael. I really appreciate it. And
Thank you.
If you got to drop, go ahead. I can take us all out.
Okay.
No big deal. Again, thank you very much
for following. Bye-bye.
Yes. Check out more stuff on ServiceMesh over at, I can find the link real quick. ServiceMesh Red Hat. I should have this memorized, but you would think that. Nope. Oh well. Here we go. All right. Copy link address. I'm going to drop it in here because for whatever reason the normal chat is not working. So there you go, everyone. If you need any assistance or you would like to learn something else on the stream, please let us know. You can reach out to me on Twitter at Chris Short. You can email me at cshort@redhat.com. And we look forward to seeing you again here in the very near future. Like tomorrow at noon, we will be going through a data-driven approach to community development. It's going to be an OpenShift Commons briefing with Diane Mueller and Danielle. Oh boy, Baturgia. Yeah. Danielle Baturgia. So please stick around. Come back for that tomorrow. There's a Windows container show on Monday. We are taking the day off. It's a U.S. holiday on the 3rd, so we won't be around for that. But yeah, there's a Windows container show at 2100 GMT, 1700 Eastern Time, or 5 p.m. Eastern Time. There's also a AMA on Monday about Quay, Project Quay. So please stick around for that, as well as a whole bunch of other content coming in the next week. Next Tuesday is a developer experience office hours. So please stick around and stay tuned in for all the fun things we've got going on here on the OpenShift TV platform. So with that, thank you very much. Appreciate all the thanks and congratulations on hitting 1,000 followers. That really means a lot to me. So thank you all for following, and have a wonderful day and rest of your week if I don't hear from you soon.